So, and in regression, we have the independent variable and the dependent variable. The condition for using a regression for a statistical test is your independent variable must be categorical. Why? Your dependent variable must be continuous variable. In a regression, oftentimes it is being used for prediction, to test effects, okay, impact, as the case may be. It also comes with relationship too. Now, for regression, we have what we call linear regression. For linear regression to take place, it means that your data must be linear, and such to ensure that your data is linear, we use p-plot tests to be sure that the data is linear. Now we have multiple linear regression. For multiple linear regression, it is expected that you have two independent variable and one dependent variable. Okay, and to be able to ensure that your data is linear as well, we use QQ plots for multiple linear regression. And then for logistic regression, we have some people call it binary regression. Okay, binary regression can be yes or no, death or life, okay, male or female. All right, so oftentimes when you are running for prediction, okay, your categorical variable that is binary, and then you have a continuous variable, and then you want to see, does this predict what we are looking for? Okay, so we use logistic regression. Then we have ordinary least square regression. Okay, that is when you have so many data, and then for instance you have so many conditions and you want to know if it actually related, or if it's actually related, there's a relationship or there's effect size among it. Oftentimes when people run for multiple linear multivariate analysis, some of them people use ordinary least square regression for such purpose. Okay, so we'll go straight away to the practical class now. I believe you have downloaded the task, so I'm not going to show it on the screen again if you've downloaded it, or let me just talk about it while you are looking at your own data set. If you look at the data set, we have gender, we have score, we have remark. There's a mistake in this remark. We have remark, and then we have method of teaching. This is a spreadsheet of a mathematics teacher. This result is from mathematics. Okay, now we have male student, female student, and their scores respectively. Now, the condition to show that you pass or fail is that you must score from 50 and above. If you score from 50 and above, it means that you pass. If you score less than 50, it means the student fail. Okay, so if you look at it, the first score here, 45, it means fail. 67, pass. Now, we then look at the method of teaching. Okay, what method did the teacher use to teach these students? We have student center, we have teacher center. Okay, now we have seen this is the score. Now, the next thing we want to achieve here is we want to see if there's a relationship between uh, gender and the score. We want to see if there's a significant effect between gender and score. We can then conclude and say, oh, female students tend to perform well in mathematics compared to male students. Okay, that is linear regression. However, we can still run a multiple linear regression. We can run multiple linear regression by using uh, gender and method of teaching. These are two independent variables. against the dependent variable, which is the score. Now, if you look at the score, you see that it is continuous. It is not categorical. You see 45, 67, 45, 68, 76, 56, 66, 48, 75, respectively. Okay, so we can then compare two independent variables using gender method of teaching on score. We can as well run linear regression. We can as well run logistic regression. Okay, so let's kickstart this. And I said we'll be using Julius AI. So I will display my Julius AI now. Thereafter, we can upload our data sets. So let's
what did
upload
you
our data
wanted?
sets. This
Okay, I've not you haven't uploaded. Okay.
yes, let's upload our data sets.
Mm.
Okay, and then let's look for the directory that you saved it. So I'm waiting for the document to attach. Okay, now we have our data sets now in front of us. You can see gender, score. Oh my, remark. Method of teaching is supposed to be remark, please, not remake or remake as we are saying here. Okay, so now we want to prompt. So I'll go ahead and then prompt this data set. I will comment by saying that clean this data sets and okay, clean the data sets and use linear regression to compare gender and score. Okay, to compare gender and score. Let me copy it before sending it. Okay, I'm going to send it. I've clicked on it and so I'm waiting for results. Okay, so let's run this analysis on DeepSeek as well. So we're going to say that uh, using linear regression, compare gender and score and present the results on tables. On table. I'm going to copy this and send to you. So you can use the prompt as well and send it. We have a result, linear regression result, gender
Hello, Mr.
versus
Samson.
score. Can you hear me?
Okay.
So we have linear regression results, gender versus score. This is the intercept. That is male. That is why we have the intercept. Then gender
Intercept.
coefficient, R squared, P value, and then observation is 14. So looking at this, it is not significant because it's 0.18. So wait for you so you can have your results.
They say no.
Now I want to compare two variables together. I want to compare if there's significant impact or does
This is what I have.
okay, let's move on. Using multiple linear regression, compare gender, compare okay, predict, let me use this word, predict the effect of gender then that, and um, um, teaching method on score. We're going to on score present the result in table. Then I send now. So we have our model summary table as well, and then we have our coefficient table as well with interpretation. All right, we're going to stop here tonight. Next class, we'll look at logistic regressions and other least square regression, respectively. If you've not subscribed, please do well to subscribe. See you same time, same venue.